The last part of this chapter is applying the distance and midpoint formulas. This should be very familiar because you did it in pre-algebra. The only difference with what we're doing this year is we're tying it into the Pythagorean theorem into the distance formula and explaining how they're related. So let's look at, and I'm essentially, I got a kind of a smaller Sharpie so I can do a better job of aligning things for you. And I'm going to draw two coordinate systems because we're going to be doing this with coordinate systems next to each other. And in both cases, I'm going to draw a triangle. And we're going to go basically up 1, 2, 3, -1, -2, -3, -1, -2, 1, 2, 3 on both sides. It's going to be the same triangle with the goal of just showing you, I'll go up 4 just to give it balance, just to show you this relationship and how we actually derive the distance formula. The great thing about knowing how things are derived is if you ever forget it, you can derive it on your own. So first we're going to place on both coordinate systems 3 points of a triangle. Point A is -2, -1. So I'm going to put a point right here, and I'm going to call that A. And I'm going to draw -2, -1. Actually, let me use a finer marker here. So, let's see. There we go. -2. -1. I'm going to draw B at the point 3, 2. So 3, 2 is going to be here. That's going to be B. And you'll notice I'm doing X in purple and Y in orange to distinguish them. So that's the point 3. And this is the point 2. I'll close the parentheses in orange, it won't hurt. And then point C at 3, -1. And this is point 3, -1. And I'm going to connect my triangle. Triangle A, B, C. Okay. I'm going to do the same thing on the other side. So I'm going to again put, and there's a reason for this. I'm going to put A. This is a point 3, 2. B and C at 3, -1. And the whole purpose of this is to show how we're going to get distance AB. So this is -2, X coordinate 3, S coordinate 3 because they're lined up. And the Y coordinate here is -1. And of course, these are both -1. This is also -1. And this is the coordinate 2. And again, I'm going to draw my triangle, which you can tell is a right triangle just because of the coordinates. Okay, so there's a reason you're seeing double. And essentially, the whole goal of this is to find out what is the length of AB. In other words, what is AB? What is the length of AB? Well, using the Pythagorean theorem, I'm starting with the Pythagorean theorem, I know A squared plus B squared equals C squared. And I just need to find what's the value of A and what's the value of B, but I'm in a coordinate system. So I know that the value of A here, of the value of A is really, these are the legs, A and B. So I guess I will label them this as A and that as B. And so this is the length AC. And B is the length BC. And I know this is going to be equal to AB squared when I do it all together. Well, how easy is it for me to find each of these lengths? Well, AC, I could just count. I can go 1, 2, 3, 4, 5 and find out that that number is 5. And that's what I'm going to do on this side because I can easily just measure. And BC, I can also count from -1 to 0 is 1, and then from 0 to 2 is 2 more units, so total is 1, 2, 3 units. 3 squared equals, and this is my unknown, right? AB squared, or that's what I want to find out. I get 25 plus 9 equals AB squared. I'm going to, if I add those together, I get 34. And if I take the square root of both sides, I get left with AB, which is also C for my hypotenuse, is a square root of 34. So I have solved that. Now, why go through all this and draw it a second time? Well, because I want to match it to your X and Y values so that we can find what X, Y values are going to give me these same lengths. So here, you can see that this is my, and I'm going to label, I'm trying to find out what's the distance from A to B. Distance from A to B, or in other words, what is AB? Well, I know that this is going to be my X value for this point B and my Y value for the point B. And this is going to be my X value for point A and my Y value for point A. And I'm going to name these. I'm going to say that this is X1 and Y1. Okay. And up here, I'm going to say this is X2 and Y2. And I want you to see that relationship. And again, I'm going to restate my Pythagorean theorem, which governs this whole system. A squared plus B squared equals C squared. But instead of calling this C squared, I'm going to call it my distance. I'm trying to find out what D is. Instead of calling it AB like I did here, I'm just going to call that D because I want to know what is the distance from A to B. Well, can I use my points, my ordered pairs, to help me find that solution? Well, looking at the distance A, I can see that this is the distance from x equals 3, right? This is my horizontal distance, if I'm saying, right, between x is 3 and x is -2, right? So here's my from 3 to -2. So what I'm going to say A is let me match the colors. x2 minus x1 squared, right? That's what my A value is going to be. Plus, what's my B value? Well, I could see my B value is this vertical distance, and I can see that I'm going from -1, right, which is my y1 value, to +2, which is my y2 value. So y2 minus y1 squared. And that is going to equal whatever it is, D squared, my distance squared. I've decided to rename it, right? Well, all I need to know now is if I want to solve for D, right? If I'm solving for D and I'm going to reverse this equation, I get D equals the square root of x2 minus x1 squared plus y2 minus y1 squared, which I'm thinking you probably remember at this point is the distance formula that you learned last year. So that is the distance formula. And let's see if it works. Well, if I plug in those values, I'm going to end up with D equals x2 minus x1 is 3 minus -2. So the square root of 3 minus -2 squared plus, and then on the y side, I get 2 minus -1 squared, 3 minus -2 is 5 squared, plus 2 plus 1 is 3 squared, and you can see